In this video, we are going to study how an ultrasound transducer works. So till now, we have seen what is ultrasound, what are the various properties of ultrasound, how the ultrasound waves are actually useful for the biomedical applications. So we have seen that actually ultrasound proves to be very useful when it comes to diagnosis, imaging, etc. Okay, so now let us see how an ultrasonic transducer actually works. An ultrasonic sensor or a transducer is an electronic device that measures the distance of the target object by emitting ultrasound waves and converts the reflected sound into an electrical signal. Okay, so basically, if you want to see the ultrasound transducer around you, I have purposely put this picture so that this kind of ultrasound transducer is what you get easily in the market. In case you are using it for some of your DIY projects, or maybe at some point of time you want to use it for your capstone projects. So if you go to buy an ultrasound transducer in the market, this is what it looks like actually. This kind of an ultrasound transducer is compatible with your Arduino microprocessor. You can very easily connect it to the Arduino, and you can see the functioning of the ultrasound transducers. Okay, so over here you can see that you have two elements over here. One element is transmitting the wave, and the second element is actually recording the echo. So this is continuous kind of thing. We had seen in the earlier session that there are different modes of transmission of ultrasound. So this two element transducer is used when you are having continuous transmission of ultrasound. So this round thing that you see, these are two crystals. These are basically piezoelectric crystals. Okay, so one piezoelectric crystal, what happens is when you give the piezoelectric crystal electrical signal of suitable frequency, it generates an ultrasonic wave. Okay, and that ultrasonic wave, it travels, it strikes the object. In the echo comes back, and that echo, when it strikes the piezoelectric crystal again, the electrical signal of same frequency gets generated. So sensor is the same, the material is the same, both are piezoelectric crystals, just that one is transmitter, one is receiver. Okay, so this is what it looks like when you go to an ultrasound center. When you go to a diagnostic center, the probe of the machine that the doctor usually uses looks something like this. So when an oscillating current is applied, it causes the piezoelectric material to vibrate rapidly, and this vibration actually generates ultrasound waves. Okay, so the structure, you can see that inside there is a piezoelectric crystal. Then backing material is just to give strength. Okay, you have two electrodes. These electrodes are basically to supply the electric current. This whole housing is actually inside a metal case, and you can see that at the outer boundary you have acoustic insulator. Acoustic insulator is required so that the signal doesn't get lost, and there is no acoustic disturbance coming into picture. So both ways, the original signal should not get lost, and any unwanted acoustic signal should not enter into the probe. And at the back you can see there's a coaxial cable. This is connected to your machine. So this is what actually an ultrasound sensor or an ultrasound probe actually looks like. So ultrasound sensor or ultrasound transducer is nothing but a piezoelectric crystal which is given a suitable electrical signal for which actually generates rapid vibrations, and that vibration generates ultrasound. Similarly, vice versa, when ultrasound strikes the piezoelectric crystal, it generates the electrical signal of similar frequency. Now, important criteria for selecting a transducer, see, now you have a variety of shapes, variety of frequencies of transducers for the same application. Like for ultrasound, you have a variety of transducers being used, So how do you select that which one is appropriate? So when in terms of biomedical, it has to be very properly selected. Otherwise, your measurements can be erroneous. Okay, so main criteria that we have to follow while selecting a biomedical transducer. Firstly, the type of investigation that is to be performed, rather that is it imaging, is it diagnostic, is it therapeutic, what kind of investigation we need to perform, that has to be thought of. Physical size of the patient matters, of course, because for a child it will be something else, for an adult it will be something else. If there is an obese patient, the probe that we have to use will be of some different specifications. Then anatomic area involved, if it is eye is involved, for example, then you need much safer instrument. But if you're putting it on the skin, you might be using a normal transducer. So which kind of anatomic area is involved, that has to be thought of. Type of tissue that is to be encountered, of course, that is important. Depth of the structure that is to be studied, because uh, up to, like you have already seen, that there is something called attenuation, there is something called half value layer. Okay, so that means what? That as your wave is propagating through a medium, the signal also gets lost. So up to what depth we want to measure, up to what depth the structure has to be seen or imaged, according to that we have to select how much frequency signal we need to incident on the particular area. Okay, so higher frequency is required for short distances and good resolution. The commercially medical ultrasonic transducers, they are available of frequencies 1.6, 2.25, 3.5 and 5 megahertz. Okay, and with crystal diameters of 6, 13 and 20 millimeters. These are the mostly commonly used commercially available medical ultrasonic sensors. Okay, so 6 millimeters with 5 megahertz transducer. This is recommended for majority of pediatric echocardiography. That means if you have to use it for a small child. Okay, first thing is that the size has to be very small. So the smallest diameter, that is 6 millimeter we are using. And since for short distances we use high frequency, so 5 megahertz is used for children, for small child echocardiography. Then 13 millimeters and 3.5 megahertz, this is used for adults, and 20 millimeters along with 3.5 megahertz, this is used for obese patients. Okay, so for echocardiography, suppose you want to perform. Echocardiography actually is what? Echocardiography means that you want to see the image of the heart with the help of an ultrasonic sensor. Okay, so if you want the ultrasound sensor or the ultrasound beam to actually reach the heart, you have to select a transducer of a suitable size such that the beam can actually go through the intercostal space. Intercostal space means the space between two ribs. We all know that the heart is enclosed in a cage, rib cage. Okay, bones are there. So between any two bones, your beam of light should travel completely, and then it will reach the heart. Okay, so definitely according to that, specialized transducers have to be designed. They have to be very small in diameter so that the beam can actually travel the intercostal space without getting disrupted. So these are some of the criteria that you need to keep in mind while selecting the transducers. In the next session, we are following up with the various applications that in which we can use the ultrasound waves.